Next, we're going to do a deep dive into the history of a topic that's close to my heart, the topic of how we understand and deal with the climate crisis. As you all know, the Woods Institute has been deeply involved in tackling climate throughout its history, and the narrative around climate has really changed dramatically. When the Institute was founded, we were working in a world where we understood that renewable energy was going to cost way more than fossil-based energy, and we're all going to have to make sacrifices. We knew that there was going to be intense politics around the issue that were unlikely to yield. And 20 years later, the landscape is just really, really different. But many things haven't changed as well. And so I am thrilled to invite a series of colleagues for a deep dive into climate with a number of threads that go through the history of Stanford, the history of the Woods Institute, and the history of our engagement with the global community. Again, I'll introduce all 5 of the colleagues that are going to be joining, and if you could come up on the stage, we'll start the conversation. So first will be Rob Dunbar. Rob is the W.M. Keck Professor in the School of Earth Sciences, Professor of Oceans, and Senior Fellow at the Woods Institute. Rob's been at Stanford longer than the Woods Institute, and he's had a huge impact on undergraduate education, ocean research, and climate research. Next time, I'm hoping we see Noah Diffenbaugh. Noah's on the university's budget committee. Their meeting ends at 2:30, and he is going to sprint over here. I'm still hoping we'll see him. So Noah is the Kara J. Foundation Professor and Kimmelman Family Senior Fellow at the Woods Institute. He's also chair of the Department of Earth System Science and a leading expert in the role of climate change in extreme events. Inês Azevedo, go ahead and have a seat wherever you're comfortable, is professor of energy science engineering and by courtesy of civil and environmental engineering. Inês is passionate about solving environmental problems that include both engineering and other topics. And she also just got final approval on a huge DOE award that is going to pursue this exact same topic. And Elliott White, Jr. is an assistant professor of Earth System Science at Stanford and center fellow by courtesy at the Woods Institute. Elliott's a coastal ecosystem scientist. He studies the effects of saltwater intrusion and sea level rise on vegetation and people, especially from an environmental justice perspective. Solomon Hsiang is new to Stanford. He just arrived in the summer of 2024, coming from his service as the first chief environmental economist in the Office of Science and Technology Policy. Sol is a professor in the new Department of Environmental Social Sciences, and he's a leader in the science of causal inference in climate impacts. So join me all in welcoming Sol and Rob and Inês and Elliott and hopefully Noah in a few minutes. While I'm getting the microphone on, Rob is going to start us off with a trip down history.
Okay, great. Thanks, Chris. How's everybody doing? It's a pretty tense week ahead, isn't it? You know, I do a lot with undergraduates here on campus, and it's positively vibrating with energy. I've never been a single issue voter before, but I am this time, and it's the topic of our panel on climate. It's so important. So I've been studying climate change for 49 years now. I've been at Stanford for 27 years, but was a professor at 2 other universities before that, 44 years altogether. And, you know, there's 2 durable creations that I am the most proud of having been involved in some way at the beginning. And that's the Woods Institute, thank you very much, and then also the Doerr School of Sustainability. The 2 go together, it's like a hand in a glove. And I think it also can be said that we wouldn't have a Doerr school if we hadn't had the Woods Institute. It taught us how to work together, how to build business models for the first time, these kinds of things, and think about acceleration. So I think we're in a great place, and I'm excited to share with you a few things. Who's controlling the slides? We could go. I have a couple of slides here.
You have to, right
Oh, this thing.
green button.
There we go. So I'll walk you through 20 years of change in my little part of climate science. Climate science is vast, right? So I developed this obsession with understanding climate change over the last 2,000 years, and I've been working on that forever, it seems like. No longer. I've switched out. But this is something called the hockey stick that made its appearance around 1999, 2000, and there's Sir John Houghton presenting this. It was in the IPCC report AR3, and it shows a reconstruction of planetary temperatures, in this case, northern hemisphere only, going back 1,000 years. That's in blue, and some other paleo climate records in green. And the light blue is this error envelope. And this thing was quite controversial because it's attached to an instrumental record of temperature in the end. That's the blade of the hockey stick, right? It makes it all the more alarming what we're seeing in the anthropogenic time. But it was very controversial. In fact, some of the skeptics came out, and a very famous skeptic called Noah Diffenbaugh, who's about to run up on the stage, he called him the goalkeeper for the hockey team when he was a journal editor, right? So there were, small data sets, only small parts of the globe, questionable statistics. And I got wrapped up in this thing. And what was good about that skepticism, it prompted hundreds of research groups around the world to dive in and do all kinds of work over the last 20 years. And we've got some things figured out now. This is what my team at Stanford does. The students love to do this work. We take ice cores in Antarctica. We dive all over the tropics, drill corals. We take sediment cores all over the deep sea. And we even dive in submersibles and collect 6,000-year-old corals that tell us the temperature of the interior of the ocean. So my very first EVP grant was to develop this pretty cool technique that we could do here at Stanford using trace elements to make a really good calibration of coral chemistry to temperature of the water they were growing in. And some of those corals have been growing for 1,000 years. So we put that together with thousands of other studies, and this is the current state of the hockey stick, right? And this is credible, it's long, it's 2,000 years, it's global, and you can see the blade has gone even longer, 1.2 degrees. And so it's super important for attribution, for climate change detection studies. It allows us to say something about what's natural, the natural variability going back 2,000 years before man's influences became paramount. The natural variability is about 0.2 to 0.4 degrees centigrade, and it happens over decadal timescales. That's what you see in the majority of that record. We know some important time periods. The medieval warm period, which we once thought was global, was really just a small part of the planet, and it doesn't affect the globe. And we also use this to understand the climate sensitivity of different forcing mechanisms like volcanoes, like the sun, like century scale changes in ocean circulation. It's why we're so confident now of the human impact on climate. I'm so confident that I've switched my science now over to solutions, right? So I'm not doing this anymore. There's kind of a hockey stick in our current instrumental temperature record as well. This is temperatures just for the month of September. This just came out a couple of weeks ago, going back to 1880. And you can see there's a century scale rise there towards the end. But 2023 and 2024 at the end there represent these year-on increases in temperature that are just unprecedented. And I can say that we don't see anything like that in the past 2,000 years, right? That's what we've been doing to the climate system. I've spent 40 years working in Antarctica as well. I've lived there for about 8 years. We don't have time to go into it now, but a lot of our research is focused on establishing melt rates of the Antarctic ice sheet. And I can just say the melt rates of polar ice are accelerating. to me, the big problem in 50 years is going to be sea level rise. It's already a serious problem, but it's about to become that much worse. And I'll also acknowledge that quite a bit of our work in Antarctica was supported by WOODS, the Environmental Venture Program, and also the big ideas from the oceans. So I'm going to finish with this. I have to give a shout out to this man, Stephen Schneider, who was so important at the founding of the Woods Institute. He was, he's a leading climate scientist, co-directed EIPER with me for a couple of years. Together we went to Copenhagen, COP15, with about 15 Stanford undergraduate students, blew their minds, but they in turn blew our minds. Such a wonderful man, massively influential. I wouldn't be doing what I'm doing now if I hadn't been around Steve for a good period of time. So I'm going to stop there and pass it on to my colleague. Thanks.
So Noah has not yet appeared. Inês, do you want to start with your comments next? So we're going to switch from the problem space to the solution space.
And I'm not sure whether it's, okay, this one works better. Let me start by, first and foremost, just thanking Priscilla, Woody, Jeff, Buzz, and Chris, because the Woods Institute is really quite a wonderful family and something very unique to Stanford and to the new Doerr School of Sustainability. I joined Stanford 6 years, it's going to be 6 years ago soon, so still fairly new, let's put it this way. And immediately upon arrival, Chris extended an invitation to be part of this wonderful community. And still today, I think there are a few instances where we are able to have the faculty with such diversity of interests to really produce interdisciplinary research. Not only that, but I had the opportunity to review some of the proposals for funding, not apply to those really actively. And I was just mind blown, really, with the type of research that our colleagues do. So a big thank you for making that happen. And it takes time to build such communities. So 20 years may seem like a long time. It is not to really build this understanding. Chris asked me to say a little bit about the interactions between climate and energy. And so I thought I would start with the good news first. And so there are some really good news. And the really good news is that over the course of the last few decades, we really saw some enormous positive developments in new low-carbon technologies. So renewables now are really get quite cheap if you put them in good, in places with good resources. Just to bear that in mind, the solar PV module back in 1976 would cost $100 per kilowatt. And right now, it's close to 50 cents per kilowatt for a solar PV module. But more than that, if we look at the cost of electricity generated, we see that over the course of the last 15 years, we went from the cost per megawatt hour of power produced going from $350 to $40 per megawatt hour. So those are big wins for energy technologies. We've also seen over the course of the last 20 years, and I'll try to bind to the 15, 20 years in honor of the Woods Institute, vast improvements in energy efficiency. Some things like lighting, I would say that 20 years ago, it wasn't a done deal that LEDs would make it to the market, right? So extremely costly. There were also ugly things in terms of design still. I remember buying an LED replacement light bulb, and no one would want that in their fixtures and in their homes. Over the course of those 20 years, clearly, the efficiency level materialized. There was learning and decreasing the cost of production of LEDs, lifetimes of about 20 to 50,000 hours, and good color quality, so a big win there. Same thing that was enabled for refrigerators and other end-use technologies. Some of it implemented via standards, and California was a leader and a pioneer early on. Some of those initiated with voluntary standards that were then implemented at the federal level. So big success story over there too. In storage too, we're seeing the beginnings of a very strong success story. So over the course of 20 years, we went from storage technologies that would cost $6,000 per megawatt hour to something like $200 to $250 per megawatt hour today. This depends on technologies and different metrics, but a critically important technology for the grid of the future in every single country. And finally, the other really big winning case for technologies over the last years has been on electric vehicles. Currently, about 1 in 5 new vehicles sold are electric vehicles. This is big, and so the adoption of that new technology is also materializing pretty fast. I'll say that both for solar PVs, for storage, and for overall vehicle electrification, this is all happening at a faster pace than what experts and technologists would assume several years ago. Now, do we have only good news? No, we don't only have good news, right? So we do have tremendous challenges that abound. And I'll tie this together on why that relates to the Woods Institutes. The world today, for us to enjoy the benefits of the quality of life that we all have and that hopefully will support future generations, does need to rely still on fossil fuels. We need that as part of our generation. They still make today 75% of our global energy use, and they will be needed in large part in the future. That also comes at a very large environmental costs. About 2/3 of the emissions of CO2 are still due to energy-related operations in the energy sector and the use of fossil fuels. Not only that, but we have all sorts of new demands that are emerging as we're trying to solve the climate problem. And so that means the electrification of vehicles would require new electricity generation to meet that demand. In the last couple of years, it has become apparent that data centers, for example, may also become a big issue, and AI overall, and the needs to power those services. All of that will require several portions of the world to build infrastructure, energy infrastructure, at an unprecedented rate, kind of substituting the existing infrastructure with something similar in scale of all the stock of power plants that we have in the United States, for example. So we do see a shift that is emerging and where the Woods Institute can really make a big difference. And it is the following: we still will continue to need innovation on new technologies, and that will continue to be important. But one of the key challenges that we'll have, in particular for this country, is how can we have deployment of those existing technologies on a timely basis, and ensuring that the communities that were often left behind or suffering from the impacts of some of the consequences of those choices disproportionately are not consistently the ones that are affected. That will require partnership with policymakers, the industry, and the communities at large. I don't know other groups that are better positioned to do that than the Woods Institute right now. So that would be definitely one of the opportunities for the future. Let me close in terms of bringing that back also to the Woods Institute on one specific thing in addition to the community that I found particularly helpful over these years, and that's the Uncommon Dialogues. I really want to provide a shout out for those efforts. In a world where really dialogue is spreading apart and positions are really hard in terms of building consensus, having a venue to have those sorts of conversations is becoming increasingly important. So I hope those continue in the future, and it's really a wonderful opportunity. And I'll stop here.
Noah came in, and I'm glad to know that the university's budget is in good shape. I hate to make you walk right up on the stage and present immediately, but that's what I'm going to ask, if you don't mind.
Sure.
And as I said, Noah's really led the issue of understanding the role of extremes in the climate change conundrum.
It's great to be here. Yes, the university budget. All right, so a few things I want to say. Number one is this photo is from fall of 2009, which is when I arrived here. And it was also the 5th anniversary of the Woods Institute. So literally one of my first on-campus events that I got to attend as a faculty member was the dinner for the 5th anniversary. So it's great to be here 15 years later. The topic here, the evolution, progression of climate science. Climate science is actually a pretty new word. So literally the first job ad that I ever saw looking for faculty in climate science was the one that I applied for here, literally. It's not that those were the first times the words were ever uttered, but it has not been that long. So I remember right around that time someone asking Kevin Trenberth, who some people in the room probably know, he's a curmudgeon, asking Kevin why he didn't call himself a climatologist and instead called himself a climate scientist. And he said, well, a climatologist adds 32 numbers together and divides by 32. So I am actually a climatologist, not a climate scientist. That's basically what I do. So I think climate science has really expanded to no longer just be documenting the trends and variability in the conditions that we humans experience, but really understanding Earth as a system, and it's increasingly becoming more and more synonymous with Earth system science. But I think that the key component is it really now encompasses causes, consequences, and solutions of climate variability and change. And without waving our flag too enthusiastically, I think Stanford and specifically the Woods Institute have really been pioneers in envisioning that footprint. I do want to say that I think that when I arrived, many of the leaders in particularly climate adaptation were here at Stanford, and I think that's still the case. In terms of future trajectory, I think we are collectively, I want to be careful how I phrase this, I think we are underinvesting in climate adaptation research, and climate adaptation solutions. If you look at the Inflation Reduction Act, it's something like 10-to-1 decarbonization to what the Inflation Reduction Act calls resilience. If you look at, I think I just saw June here, hey Jane. So we look at, if you look at international climate finance, something also like 10-to-1. And I think we're going to increasingly see this as a challenge, just because of both the simple statistics of how a shift in the mean climate creates an exponential increase in extreme events, and that combined with all of the research, much of it done here at Stanford over the last decade, but also globally, showing that, and I see Saul's right here, Saul can talk more about this, showing, empirical research showing that the impacts of extreme climate conditions are exponential. So you basically have two exponentials we're adding together. And so I often get asked, is climate change accelerating? And whether or not global warming is accelerating, the reality is that the stresses from climate change are accelerating. They're accelerating for reasons that we understand, but we're not keeping up with that acceleration. So I'm here in closing to make a pitch for redoubling our focus on climate adaptation.
Thank you. One topic that was really absent from the climate change conversations 20 years ago was the role of justice for vulnerable communities. And Elliott, talk about where we are now in the discussion of climate justice.
Yeah, I'm happy to be here. I feel a little bit like the odd person out. I wouldn't call myself a climate scientist. I'm an ecosystem scientist. All of my training is being out in a wetland, putting my hands in the soil, wrapping my arms around trees. But I really thought about how can I take those basic understandings of coastal ecosystems, apply them into a context where climate change is ravaging communities and produce a solution from it. So this is some research that I did through the Environmental Ventures Project, or program through the Woods Institute, where I did just that, where I'm combining what nature can do for us in terms of a nature-based solution, addressing the increasing extreme flooding that we're experiencing with climate change, and producing outcomes that may benefit communities. So this is, actually I want to go back. This project is focused on the Houston area. So in 2017, Hurricane Harvey hit the area. It was considered a 500-year storm. If you know anything about civil engineering and stormwater management, you design cities for a 100-year storm. So this was an event that cities basically don't plan for. And Harvey happened to not only converge with this historic climate event, but the city of Houston, if you've ever visited, is like a giant parking lot. There's concrete and pavement everywhere. Historically, there were wetlands that dominated this landscape. So it's a landscape that's being hit with extreme climate events, but has also been so altered that it's unable to absorb those. So I put together a team to go after this. As Chris said, this is more of an environmental justice framework, and the goal of environmental justice is not to say that we have to be beholden to what communities say and what they want to do, but it's about a partnership. So working with communities to help lift up their voice through our institution, through our science, but also empowering them. Now they have data to go and say, hey, we would like to see you do this, because now we have the science to show that this is beneficial for our community. Or now we have the science to say that the historical kind of disenfranchisement or the subjugation that we felt is real. Look at the data, it proves it out. So 3 of us from Stanford, myself, wetland ecologist, Dr. Khalid Osman in civil environmental engineering, and Diana Mwanga led the science component of this research. And we partnered with a local community organization called Bayou City Waterkeeper in the area. They are very embedded in the community. They hold workshops, they help educate people about wetlands, water health, et cetera. And this collaboration was extremely opportunistic. I happened to be at a conference, just sat at the table. I'm a very friendly person, so if we happen to sit at the table together, we'll learn a lot about each other in about 5 minutes. But just making conversation, this person mentioned, I'm in Houston, I'm the executive director of this organization. And I took the information down, and months later, I reached back out and said, hey, I have an idea. Would you all be interested in partnering? They said yes, and we've been running together for the past 2 years. An important part about environmental justice research is that, unlike emailing a researcher that I don't know at all, where I can just say, hey, you do this, I have this idea, let's go do it, we're already in the same world, so we have a pretty clear understanding of how to work together. When you're working with a community organization, they often have never worked with a research institution before or researchers. And so we're really having to build that trust together, because I know how to do research. They may have their own view of how to do research, but we have to have that common understanding. So really having continual dialogue on how do we develop questions together that both have a strong scientific fit, but also address the needs of a specific community. And then I have to work to understand that community. So I may be well-versed in the literature about this demographic experiences that, but I'm not just going to walk into a place and map that onto them. It's about having conversations with them to see if that's actually true for them. But also there may be things going on in their community that I'm not aware of that may affect the science that we go about and develop. And then next, we have to have continuous points of engagement. So this is some of that engagement. We went down to Houston to hold focus groups, so that's half of the research. And in these focus groups, they took us out to their wetlands and helped us kind of contextualize what their wetlands look like, what are things we should know. And a funny part about this backdrop is Houston is also at the center of producing energy for our country through the oil industry. And just behind the place where we're having some of these focus groups, you have tons of refineries just going on. And so it's a very good kind of mesh point of the natural climate or the natural areas that are being disrupted by climate change, but also the things that we still need in order to have a society that we want to function. And even some of these exhibits in this little wetland area inside their center were sponsored by ExxonMobil. And the sponsorship was because they had to do mitigation work for the environmental damages that they've done. And the critical part about where these refineries are at, they're mostly located in low-income communities, communities where they don't even know about the hazards that are going on. I grew up in Cancer Alley, down in Louisiana, And I remember like being at a friend's house and you would see a flare from a refinery in Chalmette just over the river. And as a kid, I thought, oh, that's cool. I didn't know why they would flare, but now thinking about it, it's like, wow, you're just exposed to things and no one ever comes to tell you, hey, something's going on here. So that engagement is a critical component of environmental justice, but that engagement doesn't necessarily mean that as a scientist I'm sacrificing anything. We still hold the same rigorous scientific standards through this engagement. So there's a lot up here. I'm going to walk you through it. Hold your hand. It'll be nice and comfortable. The first thing is, starting on the left, we want to do collaborative research, and we have to define that context with the community. So I could have easily just said, you know what, we're just going to do this on our own and only do this for the city of Houston and not worry about specific communities. But through working with and through this partnership, they said, hey, these communities, Northeast Houston and Baytown, were particularly hit and are still experiencing flooding. So then I thought to myself, okay, how can I angle this toward those communities without, once again, sacrificing that scientific integrity? Because we're talking about flooding, flooding can be both a thing that happens on the spot, but also because of your position in the landscape. So what we did was to take the local hydrologic network streams and really think about, if there is going to be flooding, where is that water coming from? So using the stream network, we intersected the communities with streams and watersheds to highlight the 15 watersheds that you see here. All of these watersheds are upstream of these communities or are intersected with it in such a way that if too much water falls in watershed 15, for example, it's going to continue to flow down into that community. So this was the way that we set about making this something that addresses the needs of the community while still maintaining strict kind of scientific standards of rigidity, and not rigidity, but robustness. So taking that kind of basic collaboration thing and moving forward, then we did some modeling. So we used Natural Capital Project Invest, an Invest model, which is another great Stanford product. And we wanted to model, okay, if we restored wetlands to the landscape, what amount of watershed rainfall reduction or flooding will we see? And then not only doing that for a standard 100-year event, but also a 500-year event. Because if these type of events are expected to be more common, I don't want to propose a nature-based solution that's only robust for the next 50 years. I want something that can last for quite a while. So testing this under two extremes, we're able to identify specific watersheds where the restoration of wetlands could have a very meaningful impact in flood reduction for downstream communities. And restoration in general is always something good, whereas we're not proposing developing a new technology or building something that is going to require additional CO2. So we're trying to offset these environmental harms in a way that also doesn't add to the CO2 emissions profile, which may include if you have to install a bunch of seawalls, that concrete costs a lot of CO2 to produce, and it's something that can fail routinely, so the maintenance costs, all of those things. So those were the big components that we really sought to do. And this environmental justice framework, I think, is very well situated in the Woods Institute, where it forces is a strong word, but heavily encourages interdisciplinarity. So making it easy for me to reach out to colleagues who come from a slightly different background, slightly different perspective, but pursue questions together. And it also makes it easy to pursue research like this that maybe the NSF doesn't always want to fund, or if they want to fund it, it's at a much bigger scale. So this was something, a one-off idea that I had. I pitched it to the Woods Institute. They said, hey, here's some money, let's go do it. We went out and did it. So from the kind of pitch of the idea in January of 2023 to now, we already have one paper that's being reviewed, another one that's going to be submitted, and this community has something that they didn't have before. So I think that's the power of environmental justice within the Woods Institute. Thank you.
And so to close out this series, Saul's going to talk about the power of new economic techniques for helping us understand what's at risk and how to protect it.
Great, thanks for having me here. It's a real pleasure to join this community, and so I'm just so excited to be here. I started thinking about these types of problems. I was an undergraduate studying ocean and atmospheric physics at MIT, and developed this concern about climate change and began to wonder, like, why are we not doing anything about it, right? Like, this seems so dramatic. What is happening? There's so much evidence. It was so clear. And the more I thought about it, the more I learned and began to understand that there was a real disconnect between how scientists understood the problem and intuitively could grasp what were the implications of a few degrees warming. Whereas when you go and talk to someone on the street about, oh, it's going to warm up a few degrees, they're like, well, that's okay. It was a few degrees cooler yesterday. Like, I'm still here. So helping people translate the science into something that matters to them, I realized was a big hole. And so I started doing work in graduate school, if we have the slides, at a time when other folks were starting to think about this as well. And actually in sort of climate change space, we often talk about like working group 1, working group 2. This is like the IPCC organizational framework. And so working group 1 is sort of the physical scientists helping us understand how emissions translate into changes in global mean sea surface temperature, land surface changes, ecological changes. And then working group 2, at the time that I started school, was actually run by Chris. The first time I met Chris was in Argentina. I was actually something called a chapter scientist, which is like the very bottom of the totem pole. It's like what the totem pole sits on, the soil. And Chris was like in charge. He was like at the front of the room telling us all what to do. And that's the group that takes the physical implications and tries to translate it for people. And at the time that I was starting school, I thought, well, this feels like the big unknown. This feels like the big hole in our understanding, and part of why there's a break, there's this broken link that's preventing us from taking action. So we started trying to understand, okay, how do we think about this problem? And there, a lot of decisions in government and in policy making rely on economic analysis, costs and benefits. We all think about GDP, and everybody cares about, earnings and other things. So we started thinking about this in an economic framework. There are many people who have been thinking about it since like the 70s in that framework, but it wasn't incredibly widespread. This is actually a graph from a preface to a handbook that I'm editing with some colleagues, which is just number of climate change related publications in economics. So this isn't all social science. This is kind of the world I live in. Among economists thinking about this problem. And it's interesting, you talk to economists, they say, well, economics is the study of the management of scarce resources. And so you would think that the environment would obviously be a major subject area, but it wasn't for a while. Until around 2006, it became much more interesting to people. That's actually when I entered graduate school. And if we click, one thing that happened in 2006 is actually the economics. There's a report called the Stern Review, which some of you may be familiar with. Nicholas Stern had a role in the UK government. He had formerly had many other prestigious roles in macroeconomics, and he had done a large analysis trying to articulate for folks how to think about the economic impacts of climate change. Now, in reality, the model he used wasn't incredibly innovative. It was innovative, but it had many elements from models that other people had been using. He had made some different modeling decisions, and it had triggered a lot of dialogue. Now, this was like all anyone could talk about when I was in graduate school, and so it sort of like lit our minds afire, and many other people as well. And so I really attribute this sort of kink in the rate of people studying this problem to the release of the Stern Review. But in the story of what we've been doing, I show these two graphs just to sort of demonstrate the kind of progress that has been happening as a result of all that research. So on the left, this is a page out of the Stern Review report that I spent weeks staring at. Because as I was trying to think about climate change and how much we should invest in it, what ultimately happens is when you have a large economic model of climate change and how we should make decisions, it all comes down to how climate change translates into economic outcomes. And if there's a big, strong relationship there, you should take a lot of action. And if there's a weak relationship, then it doesn't matter. You can just like ignore climate change. It's just like in the noise. And so what this is the graph describing that relationship. In this multi-hundred-page report, there's one page that described the thing that is like at the core of the model that makes the whole thing tick. And what you'll see, if you can read it, is it has like proposed functional form. Like this is basically a theory for how the climate affects the economy. At the time that this report was released and changed the world, we had no idea what was going on. It made a very compelling argument, but there was no scientific foundation on which the arguments really rested. And sort of only sort of meticulous graduate students who are combing these pages realize that. And so many of us went out into the world and started using data to apply to these problems to try to understand what are the actual relationships that link the climate to the economy and people's lives. And so I won't go through all of them. Many of them came out of folks here. Marshall Burke has done a lot of great work here. David LaBelle is a leading economist in this space. And so many folks have done work on this, but you'll see some of these are looking at GDP growth, violence, migration, crop yields, domestic violence, human health. There's lots of ways that climate change impacts people's economy, people's well-being, and sort of what I'm trying to flag here. So this is from a literature review in 2016, so this was 10 years of progress, going from sort of just this theoretical notion of someone drawing something on a blackboard to saying we have data that can link these things. It was tremendous progress that happened very quickly. And then since that, another 8 years has passed. So this is a review that I'm just wrapping up. We've gone much further now still. A lot of this has come out of the work that's happening here at Stanford, as well as many other colleagues. And we're sort of being able to paint this picture that's very coherent about how climate change will reshape sort of the human experience around the world. So on the left up there is like GDP growth, human health, agricultural yields, impacts from sea level rise. This is asylum applications for refugees traveling internationally to Europe. Electricity consumption, heating. So this is blue because we save money on heating fuels. Effects on labor productivity, and changes in sleep quality around the world. So these are just some examples to give you sort of the cornucopia of research findings. There's a bunch of stylized facts that come out. I think from all of this research, one really important insight has been that the magnitude of effects is much larger than what anyone proposed. The little story there is that when I was a graduate student, I had a paper on the effects of temperature and GDP. I showed it to my advisor at the time, Jeffrey Sachs, and he said, "You made a mistake. This can't be true. If this were true, we would know it already." And so, like many years happen, we do write many papers, and now one of my grad students says to me the other day, "Oh yeah, we all know that." And I was just like, wow, we've really come a long way. So the magnitudes were not what anyone expected or intuitively imagined. It was just like a lack of creativity. The other thing is that you see tremendous inequality around the world. So these maps kind of have this like red band through the middle in many cases, and that sort of has highlighted a global discussion now about how unequal the impact of climate change is on people's lives. And then many of these are things that you wouldn't traditionally call economics, like sleep quality or human health. And so the impact of the climate on well-being is something that's now being discussed in all of these frameworks. So the reason why this matters, I think now all this progress that's occurred, Chris just mentioned, and Jane is here. I was working for Jane in OSTP just a few months ago as the first chief environmental economist in this space, and I think just the fact that Jane had the insight to hire someone like me to do that kind of work demonstrates the new linkages that are emerging between sort of economists and scientists trying to help explain to the world why this matters, and it's getting a tremendous amount of traction. So, for example, the EPA just released a new social cost of carbon, which is a monetization of the economic harm from carbon emissions that can be applied in policymaking. Our central banks around the world are accounting for climate change in their planning. The Congressional Budget Office is now accounting for climate change when it does budget projections. The Office of Management and Budget is looking at risks to the federal budget. This is like considered very serious economics at this point. The IMF is trying to always hire all of our graduate students, and they're competing with the World Bank because there's just not enough students who understand how to do this type of analysis. So it's becoming really serious economics, and as you could see from that growth in that graph, that's becoming just like a hot research area. Finally, just to close, like why am I here at Doerr? So I just moved, and I can just tell you that what is happening at Woods, at Doerr, in the broader Stanford community is really exciting. It is the most exciting place to be in this space, in my view, right now at this moment. The thing that is related to this topic that I'm describing that's happening here is that Doerr is standing up new departments. And so, my new department right now is in the Division of Social Science. It's a new department of Global Environmental Policy that doesn't exist anywhere else. And what it's going to do, the mission, is to train people to do this type of work. because this is what is demanded in the world today. And there currently are not a supply of people who are able to do the work. And so that's really the leadership and the vision of folks here at Stanford to have created that space. And I said, I want to be on that train. So that's it. Thank you.
Now I'm going to do something I do every day, usually many times a day. Molly, how much time do we have for questions? Is that 10 minutes? Okay. Well, I was going to ask a bunch of questions, but if we only have 10 minutes, I'm going to open it up to all of you. We've heard tremendous amount about the progress, but the challenges we still face. Now, what's so exciting to me is that we are in an environment where the environmental justice perspective that Elliott presents can link with the energy systems perspective that Inês talks about, and the economics of impacts perspective from Saul, plus the fundamental understanding of climate. Truly, truly unique environment, and it's what we need to make progress. So please, questions. We have 10 minutes, according to Molly. Go ahead, Jeff.
Thank you, and thank you to all for the great talks. They're really, really great. So I'll start with you, because you made a comment at the end which I thought was really important. When you look at those plots, there are differences, right? The inequality, which I think is the word you used. And there are physical inequalities, if you will. You know, people who live in Southern Africa don't have the same climate as people who live in the Sahel, for example. So there are natural inequalities as well, which could make the problem worse or better. So my question is, given that imposed physical system, are there tools, sort of economic tools that you can use, if you will, to level the playing field so that everybody, feels the same kind of impact rather than different impacts because of this imposed physical system? Do you understand what I'm asking?
Yeah. So, and there are sort of really two major sources of inequality, as you're sort of mentioning, and it's worth stating them both clearly. So one is that there are sort of physical reasons why some people might experience a more intense impact, more intense change. So like 1 degree of warming when you're at 90 degrees Fahrenheit is different than if you're at 50 degrees Fahrenheit. They just physically feel different, and different communities are at different baselines. Also, some communities have many more resources to cope, and so it makes it easier for them to deal, even if the physical change is the same. The challenge you see in those graphs is that those two effects tend to be aligned in the worst possible way, where the communities that experience the most intense changes also have the fewest resources to cope. And so I think what you're asking is, from a policy standpoint, how do we deal with that? So I think Noah mentioned that adaptation research is starting to become an important area, and I think it's partially motivated by this idea that we need to come up with better ways for people to cope. We need to figure out why people are not protecting themselves enough. And then, of course, you could imagine different mechanisms that actually move resources around. So one thing Noah and I have worked on is the notion of loss and damage, which is an idea described at the UNFCCC, which is this idea that countries that have emitted a lot might provide funds that could be used by lower income countries to help them adapt to climate change. So those are sort of the types of mechanisms I think people are talking about. I don't know that any of them have really taken flight in a meaningful way yet.
Can I build on that, actually? So layer on that, the complexity, actually, to think about climate as an intergenerational problem and tackling that issue of well-being today versus later on, as well as tying the damages from climate change to a metric of economic output versus other things. So if you end up tying that to the GDP across nations, you have even additional layers of complexity on how to cope with those inequalities. And I think that's an enormous area of research currently in climate economics. And that will be very fruitful and hopefully inform directly international policy agreements, namely for loss and damages and those streams of revenues. Yeah.
Another question. Okay, and then I saw two more hands.
My question perhaps is directed at both Elliott and Saul. Well, Saul, if you spent in 2006 just a few days staring at the Stern Reviews page, I spent a few months staring at that page that you published in Science in 2016. So there was a very nice and comprehensive study of the social cost of carbon in the US. And then a few weeks ago, your former colleague at Berkeley, David Anhoff, and others at the Energy and Resources Group published a paper in Science on the higher social cost of carbon if we were to include mitigating the issues that Elliott talked about. Now, my question is more, are there any actionable, more pragmatic solutions to the social cost of carbon numbers? Because I don't see any US policy, for example, moving in that direction to partially address the question that Professor Kosev brought up.
So I think there are many policies that could use that type of number. So the social cost of carbon is the harm caused by emitting 1 ton of carbon. And so it is relevant to many types of decisions. One way it is often framed in economics is that it is what we call the fair Pigouvian tax. So it's basically what people should be taxed for harming others to discourage a certain type of behavior. And so, many economists love the idea of a carbon tax. That is not a particularly politically viable option these days. And so but any type of investment you make, so if you're looking, for example, at the Inflation Reduction Act, and you're looking at different investments that we are making as a society, if you want to understand if those investments are cost effective, we know what the cost is, so we can compute, based on Inez's work and others, per dollar, how many tons of carbon we're saving, and then we know how much that saves us in monetary value through the social cost of carbon. So that calculation tells us whether that particular investment is worth it. And so it's a tremendously important number from that perspective. Otherwise, you could be making lots of investments that are very inefficient, and you wouldn't actually be getting back the money, for example. But there's a variety of policies, and many of them can be evaluated using this number in that kind of way, if that makes sense.
Let me build on that one once again. So I would say that pragmatism is already embedded, if possible, in the way those social cost of carbon figures are produced. There will be always some portion of irreducible uncertainties on it, and some judgments on what discount rate to use and so forth and so on. But one thing is evident, as we think about future domestic policies, having that number is becoming more and more important in that decision making. So the number is indeed used in cost-benefit analysis for any proposed major regulation across the United States, and the inclusion or not inclusion of that figure will lead to more or less stringent standards for vehicles, for new vehicles sold, for power plant-related emissions, and so on and so forth. So whereas I think improvements on the social cost of carbon will continue and are quite important, given the structure of the framework that the United States uses to move forward on some policies versus not, the key and more relevant thing is that at least you have a number, and that represents something reasonably meaningful. Yeah.
Elliott, you want to talk about the inequality consequences?
Yeah. I don't think about the social cost of carbon directly because that's, I think in my opinion, a much bigger scales than I usually typically engage with communities. But like the Inflation Reduction Act was mentioned, which has distributed a lot of money, particularly with an environmental justice framing to it. And so one example is the USDA got a bunch of money through the Inflation Reduction Act. Some of it went to the Forest Service. Myself, along with another group of people, pitched a project where we will work with small-scale landowners who are in marginalized communities that are low income in order to help them navigate into the payment for ecosystem services market, which is growing. So instead of people just having land that maybe doesn't have a lot of value to them and they're maybe tempted to convert it to something else, now they're kind of incentivized to keep that land as it is, keep that forest intact, which does flood mitigation, does groundwater recharge, does carbon sequestration, and they're getting paid to do that. So that's more of the scale that I think about, really the implementation of these policies and how can we make sure that that money is being used in a very cost-effective way while also protecting the environment at the same time.
And building on that, several of the agencies and the research ecosystem overall, including really important work over here at Stanford and in Woods, has really moved the needle in terms of understanding how to quantify the different types of inequities under an environmental justice lens, let that be due to air pollution or other different types of aspects. The danger there is that you have such a large portfolio of important indicators, and what do you do with that, right? So how do you make it implementable and actionable? So looping back to your question on pragmatism, I think that's an ongoing issue as we think about the environmental justice frameworks too.
Well, thank you, Saul, Rob, Noah, Inês, and Elliott for opening a wonderful door into where we have been and where we're headed with climate science. Thanks.